In this video, we're going to learn how to solve for variables that are in the exponents. All the examples we'll use will have bases that are sort of related to each other. So the techniques we use will exploit those relationships. When the bases are not related to each other, we'll need to use other techniques that will be covered in a different video. As we work through these examples, we'll be using the exponent properties. So you can take a moment to review those. Remember, if we multiply two exponential numbers with the same base, we actually add the exponents. And when we're raising an exponential number to a power, we multiply the exponents. And also, I'd like to highlight that negative exponents have nothing to do with negative numbers. They have to do with fractions and things being in the wrong place. Now here are the steps we'll be using today for solving exponential equations with related bases. You can refer back to these later. But the main idea is we are going to get the two sides of the equation to have the same base number. And if they have the same base, then we can say the exponents are equal to each other. And we'll be solving that equation to solve for the variable. For example, here we have 3 to the power of a plus 7 equal to 3 squared. Now these two exponential expressions have the same base. They both have 3 in the base, and they're equal to each other. So that means the exponents must be equal to each other. So I'm going to write a different equation, a plus 7 equals 2, where I say this exponent equals this exponent. And we'll just solve this equation to solve for a variable. Similarly, here we have 5 to the power of 4c plus 7 equal to 5 to the third power. The bases are the same, and these two exponential expressions are equal to each other. So we can say that the exponents are equal to each other. And we just need to use our inverse operations to solve for c. Now here we have two exponential expressions that are equal to each other, but the bases are not the same. However, the bases are related to each other. In particular, we can rewrite 16 as a power of 4. So what we're trying to do is get these two base numbers to be the same. And in this case, we will be able to do that. So we're not going to change the left side, but we're going to rewrite 16 as 4 squared. And we still have it raised to the 4th power. Now we use our exponent properties over here. We have an exponential expression raised to a power, so we'll multiply those exponents. And now we have two exponential expressions with the same base equal to each other, so the exponents must be equal to each other. So we'll write an equation that says that, and we'll use our inverse operations to solve for m. Similarly over here, we have two exponential expressions set equal to each other. The bases are different. However, there is a relationship between 3 and 81. We can rewrite 81 as a power of 3. '81 equals 3 to the 4th power, but then that's raised to the 3rd power. So 3 to the 4th power, that equals 81. So this is just a different way of writing 81 to the 3rd power. So these are exponent properties here to simplify a little bit. Now we have two exponential expressions with the same base set equal to each other, so the exponents must be equal to each other. All right, same idea here, but we'll be stepping it up a notch. In a situation like this, the first thing we should do is simplify this fraction. So 2/8 will divide the numerator and denominator by 2, so it becomes 1/4. Now we know that 4 times 4 times 4 equals 64, but unfortunately this is not a 4, it's a 1/4. However, we can rewrite it with a 4 using negative exponents. So 1/4 is the same as 4 to the negative first power. All right, that got us one step closer here. We'll go ahead and use our exponent properties to simplify these exponents. We will multiply -1 times n minus 3. And then we'll also go ahead and rewrite 64 as a power of 4. As 4 times 4 times 4 equals 64. So I multiplied n minus 3 times -1 to get -n plus 3. I rewrote 64 as 4 to the third power. Now I'll use my exponent properties. I'm going to multiply 3 times n plus 5. And now I have an equation with two exponential expressions with the same base equal to each other. So we can say the exponents must be equal. I'll use our inverse operations to solve for n. So I'm moving my n's over to the left and the constants over to the right. Now with -2/4, we can divide the numerator and denominator by 2, so that becomes -1/2. Similarly over here, the first thing we should do is simplify this fraction. The numerator and denominator are both divisible by 3. Now 216 is actually equal to 6 times 6 times 6, or 6 to the third power. So we can rewrite both of these bases as a power of 6. So 1/6 is equal to 6 to the negative first power. 216 is equal to 6 to the third power. Let's go ahead and use our exponent properties to simplify these exponents. We're raising a power to a power. We multiply the exponents. Now we can set the exponents equal to each other now that we have equal bases. Use our inverse operations to move the m's to the left and the constants to the right. Right, these look a little bit more intimidating because they have the number e as a base. E is actually a number. It's equal to about 2.7, but it's actually an irrational number that does not repeat and never ends. Now, since e is just a number, maybe we can rewrite both sides of these equations so that they have the same base, and we can use the same method to solve for x and m. Well, here we have e to the 2x power times e, or times e to the first power. When we multiply two exponential expressions with the same base, we add the exponents. So that actually equals e to the 2x plus 1. And now we have two exponential expressions with the same base equal to each other, so the exponents must be equal. So we can solve for x without really needing to mess around with the number e. So x equals 1/2. Similarly over here, We have two exponential expressions being multiplied with the same base, so we add the exponents. Now we have two exponential expressions with the same base equal to each other, so the exponents must be equal. Now we can solve for m. Now in these examples, we were always able to rewrite the bases to be equal to each other. Now that's obviously not always the case. So there will be another chapter to this story. But for now, I hope these examples about solving exponential equations have been helpful. This is Mr. Ela signing off.